To really take our smart homeness to the next level, we need to move physical things. I've done door locks, I've done a lot of blinds, and in this project, I used a motor to open and close a window. Turns out, it wasn't that hard to do, and it works great. Let me show you how I did it. Let me give you a little more background on this project. For the last couple years, I have been on a serious mission to decrease our electricity bill. I put in solar panels, I changed out all our old light bulbs for new LED bulbs, and this year, I put in one of these quiet cool fans to decrease how much we need to use our air conditioning. Our last couple of monthly electricity bills have been hundreds of dollars less than they were a year ago. One thing about these quiet cool fans is that they suck air in from the outside. So when you're running it, you need to have a window or a door open. Now you know me. I don't want to get out of my chair if I don't have to. And with Home Assistant and some motors and some smarts, I don't have to. So there's two parts to this project. One is the window. The other is controlling this fan. And then I'll show you how I put it all together with automations. First, the parts list. I'm not necessarily saying you need to buy a quiet cool fan. If I was going to do a review on the quiet cool fan, I would say I love everything about it except the name. It should be called the more noisy than the air conditioner cool fan. They really aren't very quiet, but they are very cool. So we'll give them that. So here are the other parts you're going to need. The key to opening the window is a linear actuator. Thanks to Logan for showing me his project where he used one of these to open the sliding glass door for his pet to get in and out when he wasn't home. These come in all different sizes. The one I'm using is 12-inch. It's a 12-volt motor with some fancy gearing in here that makes this end of the shaft extend or retract when you reverse the polarity of the power going to the motor. I've looked all around, and they're all somewhere between $40 and $60. Well, you can get them for more than that if you want to pay more. I don't know why you'd want to pay more, but you could if you want to. It's okay. It's cool. Some linear actuators come with mounts so that you can attach them to whatever it is you want to open and close. The one that I got didn't. So I whipped up these mounts on Onshape and 3D printed them. And they work great. Of course, I'll make this available if you want to use these. Just like with the Smart Blinds project, anytime we want to reverse the polarity on a DC motor, the easiest way that I've found to do it is to use one of these H-bridge motor controllers. They work great, and they're only about $3 a piece. And then to control our motor controller, we're going to use a D1 Mini. And that's it. Motor controller, Wi-Fi controller. Pretty much done. To control all this and to link it with Home Assistant, I'm going to use ESP Home. If you need a refresher on how to get started with ESP Home, there's a link. This is the YAML that I'm using to control the D1 Mini. Top part here is all the basic stuff. This is going to look pretty familiar if you've looked at the blinds control. We've got two pins that go to the motor controller as outputs. We create two switches, one for each of those output pins. Then a cover entry with platform template. One thing I noticed with these linear actuators, they have kind of their own built-in end stop. So when it gets to the end of its length, whether it's extended or retracted, it'll stop on its own. But if you don't do something to turn off the pin that's gone high in the motor controller, it'll just stay on. So the second part of the actions here for open and close is just a delay to wait and make sure that the window has opened or closed entirely, then a command to turn off whichever pin had to go high to get the motor to move in whichever direction you wanted it to go. Got it? If you don't do this, then these pins will just stay high until the next time. I don't know that that's a problem, but it seemed unnecessary, and this is a very easy way to get it to turn off. And then again, just like with the blinds, I wanted a push button so that when you're sitting next to the window, you could also use the button to open or close the window without needing to get into Home Assistant. Because if your house is like my house, you're probably the only one getting into the Home Assistant user interface. I don't know why they don't love it. It works so hard. Anyways, so what this says here is when you press the button, if the window is closed, it will open. If it's moving, it will stop. And if it's open, it will close. And that's it. It couldn't be much simpler than this. So go through all the normal process with this. Save, verify, compile, upload to the D1 Mini, go into integrations, and add the new ESP home device. And then you'll be ready to put it all together. So here's some hardware setup. This is my linear actuator. These are some 3D printed brackets that I made. This will be the end that connects to the window frame, and this end connects to the window itself. Here's the connections for the electronics. D1 Mini with our ESP home sketch on it. 5 volts comes from this connector on the motor controller. Ground comes from the middle connector on the motor controller. We've got D3 and ground going to the push button. And then D1 and D2 with the green and brown wires going to EN1 and EN2 on the controller. And then the motor connections go on this side. Since I'm using EN1 and EN2. If you were using EN3 and EN4, then you connect it to the other side. Now with our 12-volt power supply, not breaking any speed records, but it'll be good enough. Okay, time for install. This is the window where I'm going to install my window opener with the linear actuator right here in the window frame. This is the side that moves. I chose this window because it's in the basement, so there should be nice cool air down here from the outside. This is under a cover, so it's not going to get a lot of rain. Well, it shouldn't get any rain. And there's a plug. There's an outlet right here that I can get power from. So this seems like the ideal window. Oh, most important of all, the reason this is the ideal window is because my linear actuator actually fits. So when you buy one of these linear actuators, it's got to be the right length. This one is perfect, and what makes it nice is I don't have to put an end stop. This already has an end stop mechanism inside. So when it gets to its fully extended position, it will stop. And when it gets to its fully open position, it will also stop. So all I have to do is turn it on and let it go do its thing, and then turn it, back the other way when it's ready. And I don't have to do anything else to it. If I needed it to stop shorter than that, then I would probably have to have some sort of end stop so it doesn't just keep ramming into the window. So it's important that it be the right size. If it was shorter, that would be fine. I would just move this piece here in a little bit, and then it would be shorter. But then remember, you're only going to get this much movement. So when this thing will be open, it'll be about that far. So the window's only going to open about that much. It's not going to open the full length anymore. Not with this kind of opener, it's not. So, all right, time to start screwing it in. Quiet Cool fan has 3 speeds, low, medium, high. Depending on where you get your fan, if you get a fan, how you get it, who installs it, etc. There are a few different ways that you could control it. They will sell you, they being Quiet Cool, will sell you an RF controller if you want, or they have a Wi-Fi controller with their own app. But the way I'm controlling it is with a good old-fashioned Sonoff 4-channel Not a Pro, not an R2, just the plain old first edition Sonoff 4-channel. And it's working great. So here's my device in Tasmo Admin. We're going to go to the web UI. You can see here that this is a very old version of Tasmota, 5.12. This is old. So the setup here is going to be different if you do this now. A couple of important things. The most important thing to do with your Sonoff 4-channel, if you're using it to control one of these quiet cool fans or any fan that has multiple speeds, is to make sure that the relays are interlocked. And that means only one of them can be on at a time. What you don't want to do is turn on two of them at the same time. I'm not exactly sure what that would do, but it would not be good. If you're using Tasmota on your Sonoff 4-channel, which I would highly recommend, then the way to get your relays to be interlocked is through a console command. In this old version of Tasmota that I'm using, it's set option 14. But fortunately, in the newer version of Tasmota, it's a command with a name that is understandable. In this case, it's just interlock. So you type interlock and then 1, and then you put the numbers of the relays that you want to interlock. So in my case, I want relay 1, 2, and 3 to be interlocked. That is, I don't want relay 2 or 3 to be able to turn on if relay 1 is on. So to get that to happen, the command is interlock 1 space 1, 2, 3 and enter. That's it. So the command would look like this, except instead of set option 14, it would be interlock space 1 space 1, 2, 3. And that puts those 3 relays in one interlock group so that only one of them can be turned on at a time. That's pretty important. And it's really important to do it at this level, meaning at the Sonoff, at the actual relay level, because by doing it here, this will function even without Home Assistant, even without Wi-Fi. Tasmota does have a module type for the Sonoff 4-channel, so you don't have to do any tinkering here. It just already assigns each relay. Of course, you need your MQTT broker information, and then I put friendly names in here for each of those relays. To get my Sonoff 4-channel to talk to Home Assistant, I set up 3 MQTT switches in my configuration.yaml. Each one has a name, a command topic, and a state topic, and then a payload on and off. For the user interface for this, I've set up a whole view of just air conditioning related items. So in here I've got my 2 thermostats for the 2 air conditioning units that we use. I've got all of the temperature sensors in our house here. As you can see, some of them need a little bit of repair work. But that's where I get all the temperatures, including the outside temperature. And then over here is where I've put all of this new quiet cool setup, with the window opening and closing controls, as well as the quiet cool fan controls. I'll go in here and show you what it looks like. It's just an entity card, and then the list of all of the entities. The window control cover entity, that's this. The binary sensor, this window is part of our security system. So if there's a binary sensor that tells me whether it's open or closed. If you didn't have this, you could use something simple like a reed switch connected to the D1 Mini to do the same thing for just that window if you don't have it connected to a bigger security system. And then I've got the 3 switches from the Sonoff 4-channel that control the 3 speeds. And that's it. Nothing fancy here. So now I've got these controls here, and I can turn on or off any one of these speeds, and I can open or close the window, and I can see if the window is open or closed. But I want to go one step further with automations and make it so that anytime I turn on one of these speeds, the window will open, and when I turn it off, the window will close. So here's how I did that with an automation. So this first one has 3 triggers, and these are OR triggers, meaning if any one of these is true, this automation will fire. So the triggers are anytime the switch for quiet cool low, or quiet cool medium, or quiet cool high goes from off to on, we proceed to the next step. Then it checks to see if the window is open or closed. If it's off, that means closed. So if it's off, it will then send the open cover command, and tell the window to open. The next automation is the same thing, but instead of going from off to on, the trigger is anytime one of those switches goes from on to off. So now I've turned off the fan and I want the window to close. So it will check the condition. If the window is on, it will send the command to close that window. So that's pretty good. Now I've got an automation so that when I turn one of these fan entities on or off, it will close the window. This will take a second because the sensor is at the end. So it's given the command to close the window. I can hear that the fan turned off, and in a second we'll see that this changes to closed. It's not as slow as the blinds, but it's certainly not lightning fast. There we go. Now it's closed. Great. So that's good. I can manually control it here through the user interface, but I wanted something even more automated. So here's what I did. So every day at 7 a.m. and at 8 p.m., this automation will run. It's going to check the condition, and what it's going to look for is the sensor temperature for my outside temperature. This is based on whatever weather service I'm connected to. I don't even know. What I'm telling it to do here is if the temperature is above 50 degrees Fahrenheit and below 68 degrees, then continue on. I set this because I don't want this thing to ask me if I want to open the windows when it's 30 degrees outside. In that case, we're going to have the heater on, and I'm not going to want to run my quiet cool fan. And I also want it to be at a comfortable temperature. If it gets higher than about 68 degrees outside, then we're going to want to run the air conditioner. The second condition I set here is to check the inside upstairs temperature. This is usually warmer than the main floor. And if it's below 70 degrees, I don't want it to activate. So I set a condition that said it needs to be above 70 degrees in the average upstairs temperature in order to continue on. Great. So assuming that it's above 50, below 68, and that it's hotter than 70 in the house, we're going to continue. The action here is to send a notification to my phone that says, hey, it's really nice outside. Do you want me to open a window and turn on the fan? Then it's going to give me 3 actionable notification buttons. And the next 3 automations are what happens with those buttons. The first one is to turn the fan on low. So if I push that button, which is QC low, and I'll show you in the configuration in a minute what the setup for those buttons looks like. We've covered that before, but I'll show you again. If I press the button that says turn on the fan at low, then it will turn on the quiet cool fan at the low speed for 1 hour and then turn it back off. If I press the second button, it'll turn on the medium speed fan for 1 hour and then turn it back off. And of course, the third button will turn on the high speed fan for 1 hour and then turn it back off. To create those buttons, we need to go to the configuration.yaml file under the iOS push categories and enter this. Quiet cool is the name of the whole action box that I'm going to receive. That's the notification name. And then inside that notification, I've got identifiers for each of those buttons. And that's these. So this identifier here corresponds to this automation action name here. See that? QC med here, QC med here. Okay. And this name and the identifier here as quiet cool is what we see right here. This is the link between this automation that says if it's this certain temperatures, then send this box of actionable notifications. That was probably the worst explanation of that I've ever done. Fortunately, I've explained it a few other times, and there's a video on how to do it. So here's the test fire of this actionable notification for my phone to turn on the fan. We'll see how it goes. So I trigger the automation. This will happen every day at 7 a.m. when the temperature's right and 8 p.m. I get those 3 buttons. Let's try high. There it goes. And I can hear the fan just cranked on too. It is loud on high. very loud on high. So excellent. It's working. I guess now it's demo time. So that's it. A linear actuator and Home Assistant to open and close a window. That's not a small thing. I really feel strongly that the next level of home automation is this kind of stuff, making physical things move. That's not something that everybody will attempt, but I think it's pretty cool and pretty necessary if we really want to be like Star Trek or the Jetsons, which is really what we're going for, isn't it? There's a lot of things you can do with those linear actuators. I've also got some windows that have the crank. Instead of sliding open and closed, you crank them and they swing open and closed. So those will be the next ones that I'll tackle. Now that I've got my Quiet Cool all automated and ready to go, I'll report back in a few months on how much money we've saved on electricity this summer. That's all for now. As always, thanks for watching. Till next time, adios.